Hey, this is Alex Ketchum, Physics 2. This is the Test 2 wrapper. We're going to be going over problem 1 from the second test. This problem has two plates with a negative and a positive charge, and there's an electron that is moved from the negatively charged plates through a hole in this side and out, and is currently over here. It is on the x-axis currently. The electric potential between the two plates is 1500 volts, and outside of the plates the electric field is negligible. We're going to take the position of the electron to be right here, as it's shown, and they want us to find the magnetic field at location A, which is right here, and the coordinates are given here at 0.005, -0.01, and 0 meters. And what does the magnetic field do to the moving electron? So to find this, here's the equation for the electric field. You have the constant times the charge, which is a negative e, which is negative 1.6 e to the negative 19th, times the cross product of the velocity and the position vector divided by the position vector squared. So to find the position vector, as always, it's r equals r observation minus r source, and so we have the observation location is right here, xa. So it's going to be this vector minus the source, which is we're going to take this to be the source at the origin. And if we take this to be the origin, we can take this to be 0.005, negative 0.010, 0. And then, so it will be this minus 0 vector is going to be just the exact same thing. So we have that right here. AX, AY, A0, minus 0. Because this is AX, AY. So we have this right here. So that's the R vector. Now, to find the velocity vector, we can use the equation for delta K, which is kinetic energy. And that is found by multiplying, and delta K is the negative charge times, or it's going to be the charge times the electric potential, and here the charge is negative. I'm sorry, no, it's always negative. This is always negative in the equation. So delta K equals 1/2 mv squared minus 1/2, so 1/2 mv delta 1/2 m delta v, which is the change in velocity. We have, since it is initially at 0, it's initially at rest, it's going to be just the final velocity. So we have that here, 1/2 m, the mass of the electron, the final velocity squared, is equal to E. It was originally negative, but it's also, the Q here is negative E, so it's just positive E, times delta V. These are both constants. This is a constant, this is a constant, so we're just trying to solve for this one variable. So we move everything over, multiply by 2, divide by mass of electron. We'll get 2 E divided by mass of electron times the potential, take the square root, and we have this, and it's the vector, it's this vector right here. Then, so now we have this, now we have the velocity vector, and we have the position vector, so we can take the cross product of the two, and when you have a x and a y and an x, and you have an x and a y cross an x, and no y and no z, the x's are going to both go to 0, so it's y cross x, and y cross x is going to be z. So you have v cross r is going to be 0, 0, and then z. This is going to be the cross product of the two. So we have ay times the vector. And then, so you plug this back into our initial equation, which is right here, B electric. So you have the constant times negative E times this times the cross product of the vectors divided by the separation vector, the distance vector. We have this here. The distance vector is going to be the square root of ax squared plus ay squared. It's just the Pythagorean theorem here. This is negative because of the negative E. Pull out the negative here, get this, and then you can factor that out of the equation up here just to say that we have a z vector. You plug in your variables. We have ax given, ay is given, E is the charge of an electron, mass of electron is a constant that you should be able to know. You can just look that up in any book. Delta V is the electric potential, which is given as 1500 volts. So you multiply this all out, and this is 1 e to the negative 7th. This is constant value, and you multiply this all out, and you remember to keep your vector. This is the scalar of the vector, which is 0, 0, 1, and it'll come out to be 2.64 e to the negative 15th times the vector 0, 0, 1. So it's in the positive z direction. This is how many teslas of magnetic field is on the point due to the electron at point A. Thank you.